Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylasolio. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritia broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future.
Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second. Aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's eighth continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritia. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steppes of Mauritia. They found a mineral that exists in rocks, which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Saul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Saul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a sun-like star in 1995. To find those distant planets, astronomers used different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trip. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016 and is called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape. Kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical, or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain, or walking on a super steep slope. All because gravity wants you right in the middle of the face, and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest, and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years. Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios. More of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. That's where the idea of planetary intelligence comes in. Just like individuals and groups can be intelligent, so can an entire planet. Researchers believe we should measure the planet's intelligence by its ability to keep itself going forever. And just like how humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together towards this same goal. It's like the planet is a complex system that knows how to take care of itself. Like forests. They can share nutrients through their secret underground networks of fungi. This helps all the trees stay healthy. We can obviously learn a lot from forests. If we jump into the fantasy universe while looking for intelligent, conscious planets, we definitely choose Mogo from Green Lantern. It's a specific planetary entity that can do things like changing its weather and altering gravity, plant growth, or some other surface conditions. Or how about the stunning Pandora from Avatar? Do you remember the fascinating scenes of flora and fauna there? With organs that might remind you of tentacles. They enable creatures to interlink with each other on a neural level. It's like the entire planet is like one giant brain, with many smaller trees, creatures, and its other pieces as its cells. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora, or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials, like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering, where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora. There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, because you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. So they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least, now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane, or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again, and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, the appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path: a white dwarf star 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we miss the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.
NASA is on the hunt for Dyson spheres. Turns out there are 60 stars that give off weird light patterns. This means there might be some extraterrestrial technology nearby. A team of scientists has developed a new way to search for advanced civilizations by looking for Dyson spheres. All forms of life, from microbes to us, need energy in order to survive. As living creatures keep evolving, their energy needs grow. We started with small fires, then moved on to coal, oil, and eventually solar panels. Now imagine a super advanced civilization that has used up all the energy sources on its planet. What's next? Their host star, an almost limitless power source. This is where the idea of Dyson spheres comes in. It was made up by the physicist Freeman Dyson in the 1960s. This idea says that, hypothetically, we could build an incredibly big structure around a star to capture its energy, like some sort of gigantic solar panel. Advanced civilizations could use it to power their planet and even interstellar travel. Right now, something like this would be impossible for us to build, but maybe someone else in the universe has managed to pull that off. Scientists gathered lots of data from surveys of stars. They analyzed over 5 million objects and found some candidates. Of course, extraterrestrial civilizations might have completely different technology, so astronomers aren't looking for actual giant shells around stars. Instead, they're looking for technosignatures. These are weird things that might indicate the presence of something technological and can't be explained by known natural sources like galaxies or nebula. For example, a structure like a Dyson sphere could give off unusual infrared radiation. This is because, while absorbing a star's energy, this structure would give off crazy amounts of heat. Out of millions, they identified 368 potential candidates. Further filtering left them with only 7 objects that could be Dyson spheres. Now usually, weird infrared flickering happens from giant crashes in space, like planetary collisions. Warmed up dust and rocks get scattered around and give off strange lighting patterns. These are called extreme debris disks. The researchers think these 7 objects could be M-type stars, also called red dwarfs. These are stars that are very small on the space scale and a bit fainter than our Sun, a yellow dwarf. Stars like that don't usually have warm dust and rocks around them, but scientists need to do more tests, like looking at the light in detail, to be sure about their discovery. There was another study that found 53 star candidates with similar excess infrared radiation. But these also need to be checked. Scientists plan to use advanced tools like the James Webb Space Telescope to take a closer look at all these candidates. One famous candidate is Tabby's star. Scientists even made a joking name for it because the paper about this star had the subtitle, "Where's the Flux?" Think of an acronym yourself. Now, it's a bit hotter and more massive than our Sun. It's caught NASA's attention because of its unusual, irregular light dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turns on and off a flashlight. At first, you might think this is just because some big planet is passing in front of it, or a comet. But we're talking up to a 22% drop in light. No planet could manage to eclipse a quarter of a star, and that's where the name comes in. So, another explanation is a Dyson sphere or some similar megastructure. Someone also suggested that the dips might be caused by fragments from a broken exomoon orbiting the star. There are other stars that show similar traits, but there's no solid evidence to support this. So for now, scientists just don't know. So, astronomers are on the hunt for any giant structures. There are many variations of what a Dyson sphere could look like: rings, bubbles, a swarm of satellites, a giant shell, and so on. A Dyson shell would be a solid, rigid shell completely enclosing the star. This is the most extreme option, the hardest one to build. Also, if other civilizations built that thing, it would fully cover the star's light, and we simply wouldn't see it. The inner surface of this shell could be lined with habitats, and we could simulate gravity by rotating the structure around the Sun. A Dyson swarm is the simplest option, a bunch of solar-collecting satellites and habitats orbiting the star. It would be a lovely place, with people living in many space stations or mini space houses within the swarm. Each little habitat would have its own air, life support systems, and artificial gravity. We could also grow our little farms there. And imagine the view. We would see a constant bright sky with other habitats visible across the expanse. A near unlimited energy of a star would mean we could advance our technology very fast, manufacture tons of materials, and terraform planets within the star system. But building and maintaining a Dyson sphere would require advanced robotics, AI, and tons of money. It would take us centuries or millennia to get there. Now, giant megastructures aren't the only things that scientists are looking for in order to find extraterrestrial life. They also look at the planets. Now, planets must have certain characteristics to be potential homes. There should be liquid water and an energy source, something to drive these reactions, creating the building blocks of life. Turns out such conditions aren't rare at all. Our search showed that there might be more than 60 billion potential habitable planets in the Milky Way alone. Unfortunately, we can't look at them directly or land there. So we have to use tricks, like detecting water and good gases in their atmosphere. Recently, the James Webb Space Telescope found possible signs of life on a planet called K218b, which is pretty close, about 120 light-years from Earth. This planet is 9 times the size of Earth. It has clouds of liquid water but a different atmosphere, full of gases like methane, carbon dioxide, and dimethyl sulfide. Regular oxygen-breathing life wouldn't do well at all there, but on Earth, dimethyl sulfide is produced by life forms like phytoplankton. They also discovered that weird wiggly planets could be signs of advanced extraterrestrial civilizations. In our solar system, each planet has its own orbit. But the universe likes to surprise us. Surprise! Models show that there might be planets that share the same orbit. For example, it's possible if the planets are evenly spaced around the star, minimizing their gravitational impact on each other. Or the so-called horseshoe configuration, when planets speed up and slow down in relation to each other, moving in funny wiggly ways. These horseshoe systems can hold up to 24 planets. This is one of those things that are possible, but very unlikely without some help. Normally, gravity would immediately destabilize such systems. This means that if we ever find a star system with 24 planets sharing orbits, it might indicate that some advanced civilization decided to lend a hand. They also might contact us themselves. The search for extraterrestrial intelligence began in the 1960s when astronomer Frank Drake started listening for radio signals from space. Today, they persist. Astronomers listen for leakage radiation from other civilizations, which are radio waves unintentionally sent into space from everyday activities. Recently, they detected radio waves from YZ Ceti b, a planet super close to us, just 12 light-years away. This means it might have a magnetic field, invisible shields that are very important for protecting life from the solar radiation. But YZ Ceti b is probably too close to its star to be habitable. But there are a lot of places for such a signal to come from. It turns out there are 1,000 star systems in our galaxy where they can see us in the sky. All these stars have a perfect view of Earth passing in front of the Sun, making it easy for potential extraterrestrial astronomers to spot us. So, there are over 1,000 star systems that could be watching us right now. And if we study them, we might one day find evidence of intelligent life looking back at us. Hello! Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the Sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the Sun, it sped up, like it had a rocket on it. And it wasn't the Sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space. Time is nothing but a magician's trick. Or is it? We're used to time zipping along like a car, always pointing into the future. It creates cause and effect, lining events up one after another, like dominoes. Sometimes it stretches between moments, getting so slow it might even want to stop. And it's got a spotlight on right now because that's the only moment that truly matters. But there's a new theory that it might not exist at all. We usually think of space as having three dimensions: up and down, left and right, forward and back. And everyone thought that time was a separate thing, just a universal clock ticking away in the background, and it's the same for everyone. But then Einstein came forward. He decided to surprise everyone back in 1905 when he introduced his special theory of relativity. It said that time is another dimension, just like the others, and they're all tied together in one big space-time. Based on this, it turned out that time can change depending on the speed at which you move. Now imagine that we take two twins. Twin A stays on Earth, Twin B takes a journey into space on a spaceship moving at a speed close to the speed of light, let's say 90% of that speed. Twin B travels to a distant star and then returns to Earth. For Twin B, it feels like the journey only took a few years. But when they come back to Earth, it turns out that Twin A has aged significantly more. They find out that 20, 30, or even more years have passed on Earth. That's all because of the phenomenon called time dilation. It happens when we're reaching speeds close to the speed of light, causing time to slow down for the traveler relative to someone who stays in one place. 10 years later, Einstein proposed his theory of general relativity. That's when we learn that time changes not only based on your speed, but also based on gravity. Back in the day, Newton thought that gravity was some magical force that makes objects attract each other. However, Einstein proposed that this isn't a force, but more like an after effect. Picture the space as some huge cloth. When you throw a heavy ball on a cloth, it curves. Now, if you throw some small balls around it, they will naturally approach the heavy ball. At the same time, massive objects like stars and planets cause space-time to curve around them. When there's something super heavy in space-time, it curves the matter around it. This curvature tells objects how to move, and this is what we call gravity. This idea created all sorts of cool predictions that later turned out to be true. Bending of light by gravity, black holes, and time dilation around these black holes, just like in Interstellar. This theory revolutionized our view on everything, but we might be on the verge of another revolution. Some philosophers have a crazy claim. They say that the things we believe about time are all just ideas in our heads, not facts of the physical world. This idea, which breaks the traditional view of time, is called the block universe. It's backed up by Einstein's theory of relativity, but extends it and makes it more complicated. Imagine the universe as a huge sandwich. This sandwich contains every moment of time, past, present, and future, all at once. Each layer or slice of the sandwich represents a different moment in time, and all these layers exist simultaneously rather than one after the other. In this model of our world, the past, present, and future are all equal. Unlike our everyday experience, where the past is gone, the future hasn't happened yet, and only the present is real, the block universe says that every point in time is just as real as every other point. Imagine your birth, this moment right now, and what you'll be doing in 10 years from now all exist together in this block. It also says there's not really a flow of time. We're used to time flowing from one moment to the next, even with Einstein's theory. But in the block universe, the feeling of time moving is more about how we experience and remember events than about how time itself works. It's like reading a magical book. All the pages exist at once, but you can only experience the story page by page. Now, this implies some scary things, like destiny, and whether free will actually exists. If everything is already laid out, does what we do matter? For example, you clicking on this video was already predetermined in the block universe. Every choice you've ever made was an illusion. You're just a program following a code, but with an ability to understand its consequences. This would explain why we order junk food at midnight, knowing that it's a bad idea that we're going to regret. But some scientists argue that time's flow and direction are as real as it gets, because cause and effect still exist. If your birth, current moment, and you in the future with gray hair all existed at the same time, you'd be able to visit your past self at any moment, and already knew what your future self is like. So this whole debate might just be about how we piece together our stories of the past, not proof that the future isn't waiting to unfold. There's also a never-ending battle between general relativity and quantum mechanics, which only adds spice to the debate. On one hand, general relativity plays with time like it's a stretchy Play-Doh. The flow of time can stretch or compress depending on the speed or gravity. On the other hand, in quantum mechanics, time isn't something that can be manipulated or changed. It's a constant stage upon which the particles and forces of the universe perform. These two fields have been fighting for a long time now, and scientists are struggling to unite them in one cohesive theory of everything. Although there are some candidates who try to merge them in a logical way, like string theory. Now, string theory sounds scary, but it's simply saying that the entire universe, with all its particles and atoms, is made up of ultra-tiny vibrating strings. Each string can vibrate in separate ways, like the strings on a guitar, and in many dimensions. The way these strings vibrate determines what type of particle they will be, like an electron or a quark. Another idea, called loop quantum gravity, says that space and time are made of tiny loops. Whether it's strings or loops, unfortunately, they would be so tiny that we simply don't have strong enough equipment to check them out yet. So until we test these theories, they can't be proven. What's interesting is that both ideas don't really need time to explain how the universe works. We think of things like tables and chairs as real, even though physics doesn't describe them directly. We say they emerge from the tiny particles that make up the universe. But with time, we're not sure how it would emerge from something else. But no matter what the answer is, you're going to be okay. If it turns out that it doesn't really exist, then it could make everything feel pointless. But think about this. We still lead our lives, and we still experience what feels like causation and make sense of everything. It still feels like it was our choice to order that junk food at midnight. So, does that being predetermined really matter? In any case, we've been wrong about plenty of things we thought were set in stone. Right now there's a big split between the block universe and our traditional theories. But we'll learn the truth over time. You of course know that the Earth is bathed in sunlight every day. Every day we flicker different light sources on and off, mechanically, without even thinking about it. But imagine that one day, you casually flicker the lights off, fall asleep, and wake up in a completely different era. Let's see how it happened and what it has to do with light. Quantum physics is quite crazy. Classical physics is like a movie projected from start to finish, while the quantum world is like having an ability to take the remote control and manipulate scenes you're watching. Fascinating and mysterious. Let's say you have a regular light switch that can be either on or off. That's like a regular bit in computers, which can be in one of two states, 0 or 1. But in quantum computers, there's a special kind of switch, a switch called a qubit. Unlike the regular bits, a qubit can exist in multiple states at the same time. It can be both 0, 1, and all things in between, like having lights on and off simultaneously. Yeah, our universe has some weird rules. This mysterious property, called superposition, allowed us to do something incredible recently, to reverse time back. At least in a tiny experiment with quantum computers. It's the autumn of 2022. Two groups of scientists, one from Oxford and the other from Vienna, decided to conduct a weird experiment. They played around with a quantum computer to create a program that reverses time. They took a tiny electron and tried to make it go backward for a time for just a fraction of a second. It would be like breaking a billiard ball triangle, where the balls go from order to chaos and then magically reverse. But don't get too excited about time travel yet. Unfortunately, we're not sure if it's possible to recreate it in real life. The scientists cracked some numbers and found out that if we observe 10 billion localized electrons every second for the entire age of the universe, we'd only see something like this happen once. And it would only take the electron back a tiny fraction of a second. So they didn't invent a time machine. They just managed to create this simulation in quantum computers. There's another catch too. The larger the simulation, the more complex and less accurate it becomes. In our experiment, we only used 1 qubit and we managed to reverse time. In a 2-qubit setup, scientists could reverse time only in 85% of cases. And in a 3-qubit setup, it dropped to 50% with more errors. If we keep adding more qubits, we won't be able to pull this off at all. Plus, the success depends on the amount of information the system can store. For example, teleporting a person would be almost impossible because humans have so much information inside them. So, unfortunately, no time machine so far. But there are some possible uses of this discovery. Reversing qubit states in a quantum computer can help correct errors during development, sort of like a little Control-Z in real life. So, it was a tiny step to more exciting discoveries in the future. For example, recently they demonstrated another crazy little thing: send light itself back in time. Now, light isn't mere luminary. It has superpowers that we can't even imagine. The ancient Greeks believed that our eyes emitted visionary beams. Sir Isaac Newton proved them wrong hundreds of years later when he conducted his experiments with prisms. The prism broke the pure white light into a beautiful palette, and that's how we found out that light actually consists of tons of different colors. Many years later, scientists learned even more, that light is a wave. And even later, in the 20th century, we discovered the final paradox, that it's both a wave and a particle, a dual existence in one photon. And the more we learn about light, the more crazy things we find. In 2016, scientists managed to freeze the light in time. They put photons, the tiniest light particles, in ultra-cold atomic clouds. Then they managed to stop it, again, for just a moment. But the fact that it's even possible is already incredible. Then scientists got even bolder. They decided to try not only to freeze the light, but to move its direction in time. They took a special crystal and passed a photon through it, thus initiating the so-called quantum time reversal. As a result, the photon started moving into both the future and past at the same time. The science magic behind this involves 2 quantum principles: superposition and quantum symmetry. We already mentioned the first one. It allows tiny particles to exist in multiple states at once. Now, the second principle says that even if you flip particles around like a mirror, they'll still follow the same laws. Combining this, scientists crafted a photon that defied the usual forward march of time. But again, it's nothing super fancy yet. This time flip only works for specific particles, not entire humans. And even if it did work for us, rewinding a person even for a second would take a super long time and a lot of energy. But the fact that we can change the light's speed and make it change directions is already amazing. And scientists already see some possible applications to this. For example, Harvard researchers suggest a cool way for spacecraft to zip through space at the speed of light, by hitching a ride on supernovas. Usually, traveling to other stars takes an insane amount of energy, but these scientists have a wild idea. They think that spaceships could use natural events like hypervelocity stars and meteors zooming from supernovas to reach super-fast speeds. It's kind of similar to how sailing ships catch the wind. Advanced civilizations could use these energy bursts to speed up their spacecraft. Imagine a cool spacecraft with solar or magnetic sails harnessing the power of a supernova boom. These sails could use the pressure of the sun's radiation to work, so that we wouldn't need any traditional engines or fuel. Plus, these sails concepts are much lighter and cheaper to launch into space compared to regular spacecraft. The team is already working on a light sail accelerated by lasers to reach 20% of the speed of light. It might not sound like a lot, but it's actually an insane speed. Their dream is to help humanity make a swift journey to Alpha Centauri in just 2 decades. Isn't it amazing how many things we can do with light, and not just in our imagination? Let's go to more practical achievements. Recently, a Canadian camouflage company called Hyperstealth Biotechnology Corporation has crafted an actual invisibility cloak. The wizardly cloak doesn't need any power source, is as thin as paper, and won't break the bank. Hyperstealth envisions a world where this material can cloak people, vehicles, ships, spacecraft, and even entire buildings. It's still in a prototype phase, but it already works pretty well. They name this incredible technology quantum stealth. It bends light in a way that can make objects disappear from sight. It can render objects nearly invisible, not only in the visible spectrum, but also in ultraviolet, infrared, shortwave infrared, and it even throws in thermal spectrum blocking for good measure. The technology works thanks to the lenticular lens, a corrugated sheet with outward curving lenses. When stacked in a specific way, these lenses refract light at various angles, creating spots that block light and conceal the object behind the material. Unfortunately, it doesn't give you a full invisibility effect, but maybe someday we'll achieve it, if we keep working on it. If you hide behind it, it will look like a little dirty or blurred glass, but you won't be visible. If you put this veil in front of your body, you'll look like a floating head. Scientific progress is in full swing. Maybe one day we'll be able to reverse time not only for little light particles, but for entire humans. Until then, let's enjoy our invisibility cloaks and stay curious. Okay, so you've seen the movies and read the books on time travel. Most of them tell stories about entering some futuristic boxes, and in the blink of an eye, you're in some different epoch. For now, this is just sci-fi. But there are ways to make time travel possible, at least theoretically. We just don't have the technology figured out yet. For starters, time travel to the future could be achieved by traveling at high speeds, but not just getting a ticket on the superhighway kind of speed. This is based on Einstein's theory of special relativity. It explains that time slows down for objects that move at really high speeds. And the good news is scientists have already tested this theory, and it looks promising. They did it with the help of 2 identical clocks. One was placed on a jet, and one stayed on the ground. They found that the clock on the jet ticked slower than the one on the ground because of how fast the jet was moving. The faster an object is moving, the more time will slow down for it. Currently, the fastest speeds achieved by human technology are seen in a special type of particles called neutrinos. Some of these can move at almost the speed of light. At these speeds, 1 second for the protons is equal to 11 months for us. Now, we might be able to time travel to the future with the use of gravity, too. This idea is based on Einstein's findings, namely his theory of general relativity. Now, this theory explains that the stronger gravity is, the more slowly time moves. This means that as you get closer to the center of the Earth, the strength of gravity increases. And if you think about it like that, time actually passes more slowly for your feet than for your head. Now, is that why I'm always late for stuff? Good excuse. This effect has been measured too, with the help of the same strategy with 2 identical clocks. Scientists placed them on shelves at different heights and measured the rate of ticking. The clock on the lower shelf ticked more slowly because it experienced a slightly stronger gravity. But this option comes with a catch. To be able to travel to the far future, you'll need to find a place with extremely strong gravity, like a black hole. That's a point in space where the gravity has so much force that even light cannot escape it. There, gravity becomes so intense that matter gets squeezed into a tiny space. The closer you get to the black hole, the more slowly time moves. However, traveling via a black hole is very dangerous, mostly because it's a one-way ticket. Once you cross its edges, there's no coming back. Now, here's a fun fact. The GPS systems we use on our phones and in our cars already have to account for time dilation effects in order to work properly. That's because of the speed of the satellites they use and the gravity they feel here on Earth. Without these corrections, your phone's GPS wouldn't be able to pinpoint your location on Earth very precisely. Meanwhile, the third option has less to do with the universe's unknown forces and more to do with our own bodies. Scientists are trying to find ways to time travel to the future by slowing down the body's own processes. It's not time travel per se. You wouldn't technically be going anywhere. But if your body stays put for a long period of time, you could eventually wake up in the future. Some animals, like bears and squirrels, can slow down their metabolism during hibernation, which means they don't need as much food and oxygen to survive. Specialists are trying to figure out if humans can do the same thing. They're working on ways to make people go into a short-term hibernation for a few hours to begin with. This could be helpful for medical emergencies too, in order to help a person before they can safely get to the hospital. In 2005, scientists were able to slow down the metabolism of mice by exposing them to a small amount of special gas. However, when they tried to do the same thing with larger animals, it did not work as effectively. Our fourth option of traveling through time is really unique. It involves a special type of shortcuts that may exist in our universe called wormholes. Now, before we move on, let's try to understand what they are. You'll need to picture two balls and a trampoline. If there's no pressure applied on the trampoline, it stays flat. Now imagine the two balls placed on the trampoline symmetrically. If you look at them from this perspective, there's no possibility of them ever touching. But if you put enough pressure on the trampoline between the two balls, this flexible fabric can stretch so much that the two objects might potentially touch each other. The same thing happens with stars in different star systems. They're big enough to curve space around them. That's why most planets tend to orbit around a star. The tunnel between those 2 points would be a wormhole. These wormholes could be used to travel long distances, like 1 billion light-years, or even visit different times. Now, many scientists, like Stephen Hawking, think that wormholes might appear and disappear, but be very small, smaller than atoms. The problem is that we don't know how to catch one and make it bigger so that people can use it. This would take a lot of energy, and we don't know if it's even possible. Some astronomers say that even if we could find a wormhole and enter it, it would rapidly collapse on itself. Even the tiniest bit of extra mass, like that of our bodies for example, can result in the wormhole slamming shut, like a rubber band that's been stretched too much. Now, the fifth solution for time traveling was proposed by an American physicist named Ron Mallett. It involves one resource that we know for sure is abundant in the universe: light. The scientist proposed a theory about time travel that would use a rotating cylinder of light. He believes that if something was dropped inside this swirling cylinder, it could be moved in both space and time, similar to how a bubble moves when you swirl it with a spoon in your coffee. According to Mallett, the right shape of the cylinder could allow for traveling to both the past and the future. The physicist has been trying to raise money for an experiment to test his theory. This experiment involves dropping tiny particles, called neutrons, through a circular arrangement of spinning lasers. However, other scientists say Mallett's theory is impossible and there's no need to test it further. Well, even if we eventually figured out a way to travel back in the past or to the future, would it be safe? Scientists have been talking about a problem called the paradox of time travel for a long time. The main question is what would happen if you went back in time and did something that changed the future. However, a new study from researchers from the University of Queensland says that this problem might not be real after all. The scientists have done some calculations and found out that even if you had changed something in the past, the timeline would still end up the same way. Another variation of this problem is called the grandfather paradox. Imagine going back in time and preventing your own grandfather from having offspring. Come to think of it, it automatically means you shouldn't exist in the first place. If your grandparents didn't have your parents, how can you exist at all? Well, these days scientists are certain that even if you did experience something like that, you'd still exist in the present. That's because the timeline that already exists has a way of adjusting itself, regardless of where people are in time and what they do. Or somehow get 1.21 gigawatts in a DeLorean and make like Marty McFly.
Time runs like a river. It has direction, always advancing. It has a certain duration, periods between events you can measure. Time feels real, always there, unstoppable, moving forward. But what if I told you that time might not exist? Some physicists and philosophers claim that there might be no such concept as time, and we should take this possibility of the non-existence of time seriously. You see, recently physics has been in crisis. For the past century or so, two extremely successful physical theories have been used to explain the universe. Those are the theory of general relativity and quantum mechanics. Quantum mechanics describes how things work in the super tiny world of particles and their interactions. As for general relativity, it provides an outlook on the bigger picture, for example, gravity or how objects move in space. And even though both of these theories seem to be working really well, they are believed to conflict with one another. That's why some scientists think that they need to be replaced with a new, more general theory, like quantum gravity. This idea might be able to explain how gravity works at the miniature scale of particles. Apparently, it's incredibly difficult to produce the theory of quantum gravity, but it might be possible to do it with the help of string theory. It replaces particles with strings, vibrating in 11 dimensions. But there's one problem. Even though string theories do provide several models describing the universe, they don't make any clear predictions that can be tested by experiments to understand which model is the correct one. There's one more idea known as loop quantum gravity. According to it, the fabric of space and time is made of super tiny chunks, loops. But the most remarkable aspect of this theory is that it completely eliminates the concept of time. Now suppose this idea turns out to be correct. Will it mean that time doesn't exist? Well, the answer is kinda complicated. Everything depends on what the word exist means. A philosophy professor from Cambridge University claims that the three basic properties of time, a present moment that is special, the flow of time, and its direction, come from our mental states and not from the physical world. So we sense this arrow of time because our minds add a certain subjective ingredient to reality. At the same time, Einstein's theory of relativity supports the idea of the block universe, a four-dimensional space-time structure where time is like you realize that you need to isolate part of it and call it, let's say, your watch. And time is basically the relationship between some parts of the universe and that thing you called your watch. Another scientist says that time is just a collection of snapshots describing our reality while continuously changing one into another. Here, you hit play. Here, you're blinking while watching this video. And here, you're taking a sip of your coffee. Without these changes, there wouldn't be any notion of time. The changes are real, but time is not. Our brain sees these changes and constructs a sense of time, believing that it's flowing. What do you think? Is time just a social construct, or does it really exist?
Traveling in time appeared in many sci-fi movies, but every law of physics claims that the only way we can move through time is forward. Well, thanks to some very exciting properties of space and time in Einstein's general relativity, going back in time seems to be possible after all. According to Einstein, space and time are not separate entities. They're woven together in the fabric of space-time. There's also a quantity that generalizes the concept of distance into 4 dimensions, the space-time interval. It takes into account distance in time. In other words, if you're resting, your spatial position doesn't change and you're moving through time forward at 1 second per second. But if you're moving and your spatial position changes, you travel through time more slowly. All because objects in relative motion experience something known as time dilation. Roughly speaking, the faster you travel through space, the more slowly you move through time. More precisely, time dilation is the difference in elapsed time as measured by 2 clocks because of a relative velocity between them. The faster the relative velocity, the greater the time dilation between them. with time slowing to a stop as one clock approaches the speed of light. However, keep in mind that we only know about massless objects, such as photons, that travel at the speed of light. Theoretically, if you could move faster than the speed of light, you'd become a tachyon, a hypothetical particle that always travels faster than light. Also, there is the energy-momentum relation that connects energy, momentum, and mass. One can see from that relation that if a particle moves faster than speed of light, then its mass is imaginary. So, this possibility is an unphysical situation, since tachyons don't correspond to anything that exists in our physical reality. However, Einstein thought that going faster than the speed of light wasn't the only way to travel backward in time. Space-time might not be flat and unchanging. It can be curved, can contract and expand, and can even create and maintain a connection between two different points within it. This possibility is known as an Einstein-Rosen bridge. If you jumped into one point and your friend jumped into the other, you could meet somewhere in the middle. At the same time, this tunnel wouldn't be passed through, and you wouldn't be able to get out on the other side. Now, try to imagine space-time as a two-dimensional sheet of paper. If you fold it, 2 points that were previously separated will become connected in this new two-dimensional world. This property of space-time might be the most important concept of time travel. You probably know this concept under the name of a wormhole. And it's tightly linked to black holes, regions of space containing so much matter and energy that any light emitted from that region, as well as any matter and radiation that falls there, will never escape. And it doesn't matter how much energy it has or how fast it's moving, even if it's the speed of light. Usually, it's assumed that black holes only lead to a central singularity, and if you fall behind the event horizon, also known as the point of no return, there's nothing but destruction awaiting you. But how about another possibility? What if black holes could actually transport you to another universe? Then, you would be expelled on the other side through something called a white hole, a time-reversed solution of a black hole. But so far, all this sci-fi theory is just a hypothesis. What we do know is that minuscule quantum fluctuations exist in our known universe. They occur throughout the fabric of space-time, most prominently on the tiniest of scales. Such energy fluctuations can occur very close to one another. They are most likely random and often include disconnections and reconnections from the original positive and negative states that initially occur together. If you somehow connected such positive and negative curvature regions together, you could get close to the notion of a quantum wormhole. And if such a wormhole remained intact for a long enough period of time, you could transport a particle through it. In other words, it'd instantly disappear from one location in space-time and reappear in another. But why is a wormhole so crucial when we talk about time travel? Because once you create two ends of a wormhole and maintain the connection between them with sufficient mass and energy, this connection will remain eternally. And since this is great for instantaneous travel through space, probably we could extend it to traveling through time too. Sadly, at the moment, it's just wishful thinking. Does time really exist? Our brains don't actually have a built-in clock, which is why 5 minutes on social media feels a lot shorter than 5 minutes staring at a wall. Albert Einstein, one of history's greatest physicists, once challenged the notion that time was linear. He said that if you put your hand on a hot stove for a minute, it would feel like an hour. But if you sat with someone you liked for an hour, it'd feel like a minute. What Einstein meant was that time is relative to each person and situation. So, the big question is time just something humans made up? Our experience of time varies based on factors like attention, emotions, and memories. After all, time flies when you're having fun. Studies even show that time seems to move faster the higher up you live. Interestingly, time isn't controlled by a single part of our brain. Instead, multiple areas, like the hippocampus, cerebellum, and frontal cortex, all play a role. We also sense time based on how our bodies feel. Depending on the time of day, we might feel energetic, sleepy, or hungry, thanks to our body's internal clock, known as the circadian rhythm. This 24-hour cycle helps us stay aware of the time and manage our daily functions. Even animals like goldfish and dogs can sense time. They know when it's time to eat, even without understanding the concept of hours and minutes. This shows that our sense of time goes beyond just clocks and calendars. Time is everywhere. In the changing seasons, the sun rising and setting, and in how we age. It moves forward from the past to the present and into the future. Famous physicist Stephen Hawking talked about how time has a direction, always moving forward. But then, do the past and future really exist? Our view of time is tied to what we experience in the moment. For a long time, people thought time flowed from past to future in a constant way across the universe. But in 1905, Einstein introduced his theory of general relativity, which showed that time isn't the same for everyone. According to his theory, time depends on how fast you're moving, and this idea is known as time dilation. However, the direction of time is the same for everyone. Einstein also came up with the idea that time and space are linked together in a fabric called spacetime. This fabric can bend around objects with a lot of energy, like the sun, which is why planets orbit around it. This bending creates what we call gravity. Time doesn't flow the same way when we look at it on a cosmic scale versus a biological one. In the space-time continuum, there's no clear-cut now that applies to everyone. And someone's now might be different from yours because of how time and space interact. In the special theory of relativity, there is no absolute time. It is different for each observer. However, there is a concept of proper time, the time measured by a clock following a particular line in four-dimensional space-time. The lives of each of us are these trajectories, and while on the one hand, time is not unique, on the other hand, for the given observer, time is unique. So, while time seems to exist, it's also a social construct we've created to help organize our lives. We measure events in seconds, minutes, and years to keep things in order. Without time, our modern world would be chaotic. Despite the latest findings in physics, the fact that we still rely on time in science and our daily life shows that time is more than just a social construct. And even if time is eventually proven to be an illusion, it's still a crucial part of how we live and understand the world.
The morning is cloudy, but it isn't raining. So you grab your bag and head off to work. You're halfway there when it starts drizzling, then raining, then pouring. There's only one thought in your head as you're dashing through wet streets towards your office building. If only I could hop in a time machine and go back in time. I'd have put that umbrella in my bag. Unfortunately, going back in time is not possible. But guess what? We still managed to travel in time. But let's start from the very beginning. More than 100 years ago, a famous scientist called Albert Einstein, I bet you've seen his most popular photo, came up with a theory about how time works. He gave it a nice little scientific name, the theory of relativity. According to it, space and time are linked together. Another point is that our universe has a set speed limit. Nothing can move faster than the speed of light, which is 186,000 miles per second. Okay, you may say, but what does it have to do with time travel? Well, the theory of relativity also claims that the faster you move, the slower you experience time. And several experiments prove this to be true. For example, let's say you have two clocks set to the exact same time. You leave one clock at home and take another one with you while traveling by plane. What's important here is the fact that the plane is going in the same direction as Earth. After your plane finishes its flight around the world, you can compare the time on the two clocks. You find out that the clock that traveled with you is a bit behind the clock that remained on the ground. Because of this, GPS clocks are corrected. GPS satellites travel around our planet at tremendous speeds, around 8,700 miles per hour, and more than 12,000 miles above the surface of Earth. This speed slows GPS satellite clocks down, but the altitude speeds them up. As a result, the clocks on GPS satellites experience time at a rate that is slightly faster than 1 second per second. And if this difference in time wasn't corrected, you wouldn't be able to use GPS to figure out your exact location. In any case, this is probably the closest thing we have to time travel. You see, our planet is constantly moving around the Sun at an average speed of 67,000 miles per hour. The Sun, along with the entire solar system, is, in turn, circling the center of our home Milky Way galaxy at a staggering 140 miles per second. And the Milky Way itself is also moving. It's spinning at a speed of 130 miles per second. Those are some really dizzying numbers. And now imagine that in order to get to the past, all this space matter must also turn back and return to its original position. Just admit it, it's absolutely impossible. By the way, even though we can't exactly travel back in time, we can look at the past, thanks to NASA's space telescopes. They help us see stars and galaxies that are insanely far away. It takes the light coming from them ages to reach Earth. That's why when you observe those distant worlds, you see what they looked like a long time ago. Now, what if time travel was somehow possible? Wouldn't all the fun be spoiled by the time travel paradox? You know, like finding yourself in the past and accidentally preventing your parents from meeting each other? The problem is that Einstein's theory of general relativity theoretically allows a person to travel back in time and come in contact with their past self, which can potentially endanger their existence. But you can breathe out. Some scientists at the University of Queensland have recently claimed that this paradox might not actually exist. They say that even if you made some changes in the past, the timeline would self-correct anyway. In other words, it would still ensure that whatever event sent you back in time would still happen. One more study claims that even if some changes happened in the past, they wouldn't drastically alter the future.
Billions of years ago, our whole solar system was nothing but a big cloud of dust and gas floating in space. Then, something happened to disturb that cloud, but scientists still aren't sure what exactly it was. It could have been a distant star that turned into a supernova with a bang that caused the dust cloud to start spinning. As it spun faster, the dust and gas got pulled into the center and created a thick, spinning disk called a solar nebula. The gravity at the center became so strong that hydrogen atoms started crashing into each other, producing helium and a lot of energy. As a result of all these space shenanigans, we got our sun about 4.6 billion years ago. This process used up more than 99% of the dust and gas in the big cloud. The leftover stuff started to come together to make different shapes. The cloud kept spinning, and bits of matter bumped into each other and stuck together. Some of these clumps got big enough to have their own gravity, which pulled even more matter to them. This is how the planets, including our Earth, were made. You wouldn't recognize our planet, though, as it was nothing like we know and love it today. It was hot, and I'm not talking about perfect beach weather hot. It was scorching hot, as it was mostly made of magma, which is basically melted rock. Just imagine how hot it should be to make the stones melt. After a few 100 million years, Earth started to cool down. As the planet changed and its outer crust started to form, there were lots of volcanic eruptions. These volcanoes released water vapor, ammonia, and carbon dioxide into the air around the planet. Slowly, oceans started to form from the water vapor. The planet was every introvert's dream back then, with not a single living being around until the day when the first simple life forms began to appear and live in the new oceans. Those tiny organisms were single-celled microbes that gave birth to all future lives, including yours. They left signs in rocks that are about 3.7 billion years old. The signs were a type of carbon molecule made by living things. Then, at least 2.4 billion years ago, cyanobacteria evolved. These were the first organisms to make food using water and the sun's energy, and they released oxygen. This caused a big increase in oxygen, which made it hard for other microbes that couldn't handle oxygen to survive. Then, tiny microbes started living inside other tiny microbes. This way, they were forming organelles, small structures inside a cell with a specific function. One important organelle is called mitochondria, and it helps turn food into energy. For the first time, DNA got packed inside a part of the cell called the nucleus. These new complex cells, called eukaryotic cells, had different parts that each did a special job to help the whole cell work better. Soon enough, the earliest animals would rule the world. But don't get your hopes up. They weren't fluffy kittens. All the changes on Earth were happening against the background of the supercontinent Rodinia, which formed around 1.2 billion years ago. It pulled together almost all of Earth's land masses into one gigantic piece of land. It was surrounded by a massive ocean, so the whole planet looked like a giant land and sea puzzle. Unlike the green, lively continents we have now, Rodinia was barren and rocky, with no plants or animals on land. So, early life forms like algae thrived in the ocean. The breakup of Rodinia caused changes in Earth's climate and ocean currents. New coastlines and environments eventually helped diversify life on Earth. Cells began living together and finally evolved into the first animals around 800 million years ago. Sponges, and I don't mean the loofah you use to shower, were some of the earliest animals. By around 580 million years ago, they had neighbors, including fronds, ribbons, and quilts. But then, another 40 million years later, which is like a minute in evolutionary time, the conditions changed. Oxygen levels rose, and the first animals were replaced by new life forms. It was the beginning of the Cambrian period, the time of the giant shrimps and other creatures you'd rather never meet. Those invertebrates that ruled the planet looked so weird and not Earth-like that it took scientists years to realize these scary creatures were actually the ancestors of modern mollusks and crustaceans. Meet Hallucigenia, a creature with 7 or 8 pairs of spindly legs, the same number of paired spikes coming from its back, and a head you won't tell from its tail. Another cool creature from that period was the abnormal shrimp. Unlike most animals back then that were tiny, it was over 3 feet from head to tail. There was also the Weewaxia, that looked sort of like a stegosaurus, but without a head, a tail, or any legs. It looks like these creatures were born without defensive spikes and grew them as they got older. If they ran a beauty contest in the Cambrian period, Aishia would likely win. It had many common features with today's tardigrades. Although it was just 1 or 2 inches long, it was the nightmare of prehistoric sponges, and it clung to them with its multiple claws. We still have some live souvenirs from the Ordovician period living among us. Take lampreys, for example. The marine life kept flourishing. There were squid-like nautiloids with tentacles and a special shell with gas-filled chambers that made them float in the water. They swam well by squirting water out of their bodies and used their tentacles to catch prey. Another group of sea hunters was the conodonts with their tiny fossil teeth. The few complete fossils we have found show that they looked like eels with big eyes to spot their food. Fish back then were small, with mouths that pointed downward, which helped them suck up food from the ocean floor. Lampreys and hagfish are their living relatives today. The hard-bodied arthropods, like early relatives of crabs and spiders, started exploring life on land. They moved into freshwater and shallow lagoons, and one type of these creatures was the horseshoe crab. Even though they're called crabs, they're actually more like spiders and scorpions. Around this time, the first simple plants also began to grow on land. But a surprise ice age interrupted their plans. Most of the world's land at that time came together to make a huge supercontinent called Gondwana. It included what is now Africa, South America, Antarctica, and Australia. Another supercontinent called Laurentia included what would become North America. Gondwana drifted south until it settled at the North Pole. Huge glaciers started forming over what is now Africa. This led to a 20 million year ice age and a huge extinction. At least half of all marine species were wiped out around 443 million years ago. The landscape wasn't looking too cozy, but have no worries, the first plants were about to hit the land. As temperatures rose and sea levels climbed again, the oceans began to recover during the Silurian period. Huge reef systems grew in the warm, clear tropical seas. You can still see remnants of these ancient reefs today. They are limestone rocks. The oceans were full of tiny creatures called plankton. At the top of the food chain were these terrifying sea scorpions. Some of these sea scorpions grew to over 6 feet long, and they were the largest arthropods ever. They looked like giant scorpions with huge, compound eyes to spot their prey, the primitive fish. They caught it with their strong, claw-like pinchers. Speaking of fish, they were starting to change and found new ways to eat, not just by sucking up food from the ocean floor. A group of spiny sharks developed jaws which made their mouths more dangerous. Even though these jawed fish weren't very big during this time, they were becoming better hunters and would later become top predators. On land, the first tiny, creepy crawlies began to show up. They were primitive centipedes and early ancestors of spiders. The first plants on land didn't have leaves, but they could stand up straight, thanks to their stiff stems. They also had special tubes inside them to move water and nutrients around, just like how our veins move blood. Mosses and other small plants soon followed and helped create a better environment for animals to start living on land too. The climate was nice and warm. The supercontinent Gondwana was still near the South Pole, but the big ice sheets from before melted away. Plants continued to grow and change during the Devonian period, but you'd probably be more impressed by a millipede as long as a car. If you visited the Earth back then, you'd wander in the first big forests made up of lycophytes, horsetails, and ferns. By the end of this period, the first successful trees appeared. They could grow really tall, up to 98 feet, about half as tall as the Leaning Tower of Pisa, and had thick trunks about 3 feet wide. They didn't have real leaves but had fern-like parts growing right on their branches and used spores to reproduce. The insects of that time were pretty wild. One of them was a huge dragonfly with wings as wide as a big pizza. This giant dragonfly lived in open places where it had room to fly, and its big eyes helped it spot its food, smaller bugs. It used its spiky legs to grab the insects it wanted to eat. Another monster from that time had wings about 22 inches wide and a mouth that looked like a beak. On the ground, the biggest bug ever known on Earth was wandering wild and free. It was a millipede as long as a car that likely ate fruits and seeds. The insect grew into such giants thanks to the extra oxygen in the air, up to 35% instead of the usual 21%. They could easily breathe even when they were huge, and there were no big birds to eat them, so they could grow really big and explore land and sky with nothing to worry about. But not for long. Fish started changing into the first animals that could live on land. These early fish had special fins that worked like arms and legs, and they could explore new, swampy areas where there were lots of plants and no big predators. One of the oldest animals that show this change mostly lived in shallow water, where it walked on the bottom. It had a head that looked like a crocodile's, and it could move its neck and breathe air through its nostrils. It grew up to 10 feet long. Its back fins were bigger and stronger than the front ones, which helped it move on land. At the end of the Devonian period, Earth went through 2 long extinction periods when up to 70% of sea creatures disappeared. But the plants and animals living on land mostly survived these tough, cold times. It also had a cool, distant cousin, coelacanth. This fish was almost 5 feet long and had 4 fins that looked like limbs, but it never moved to land. It adapted to life in deep water, hiding in caves during the day and hunting at night. This deep-sea lifestyle probably helped coelacanth survive 4 of Earth's major mass extinctions. For a long time, people thought it was extinct until one was found off the coast of South Africa in 1938. So yep, it still lives in the deep parts of the Indian Ocean. During the late Paleozoic era, animals including a crazy mix of a polar bear and a saber-toothed cat got all independent and didn't have to live near the water anymore. They started laying eggs on land. Fish were becoming more different from each other, and trilobites were starting to disappear. New plants called conifers were growing, and 2 new types of animals also appeared. There were marine reptiles like early lizards and snakes and archosaurs, which later turned into crocodiles, dinosaurs, and birds. This period is sometimes called the Age of the Cockroaches, because an early kind of cockroach was lurking all over the world. But there was something way cooler than a cockroach, like a mix of a polar bear and a saber-toothed cat. It was an early relative of today's mammals with long legs that helped it run fast. It had sharp, saber-like teeth that could slice through the necks of huge plant-eating animals, but it used its teeth to rip big chunks of meat rather than chew. Scientists aren't sure if it had scales like its older relatives or fur like its mammal cousins, but they found hints of ancient poop that smaller relatives had hair, so this guy probably did too. There was also a big reptile that lived in the cold deserts of Eurasia. Imagine a creature as big and heavy as a black rhino, weighing about 2,400 pounds and stretching around 10 feet from head to tail. It was covered in thick, bumpy plates all over its body, which helped protect it from predators. Because it was so heavy and slow, it couldn't run fast, so these tough plates were its best defense. To stay so big and strong, Scutosaurus had to eat a lot of food all the time. It was one of the first big plant-eating animals to live on Earth. These animals were like early versions of big dinosaurs that came later. Even though Scutosaurus looked a lot like those dinosaurs, it was not closely related to them, kind of like how we're not closely related to whales and dolphins. The closest living relative to Scutosaurus is the tortoise, another slow-moving armored reptile. When you look at this guy, Dimetrodon, the first thing you notice is the big sail on its back that could remind you of some dinosaurs, but it was actually more closely related to us. It was a proto-mammal and had some unique features, especially in its skull. It had a small hole behind its eyes where jaw muscles attached, which is something dinosaurs didn't have. Dimetrodon also had different types of teeth for different uses, unlike dinosaurs that had rows of the same kind of teeth. The sail on its back was probably used to show off and attract mates, or scare away rivals. The last period of the Paleozoic, called the Permian, ended with the largest mass extinction on Earth ever. It wiped out more than 90% of all the species on the planet. The 2 big landmasses named Euramerica and Gondwana joined together, to form one huge supercontinent called Pangaea. Around Pangaea was a giant ocean. Because Pangaea was so big, the middle of it was probably very dry, since rain clouds couldn't travel far enough to bring water to the interior. This made Pangaea's center a very dry place. The Permian extinction left room for new creatures to thrive. One of them was this guy, looking like a real-life Nessie from Scotland. It was a 20-foot-long reptile with a super long neck, even longer than its body and tail combined. And nope, it wasn't a dino yet, but a protosaurus that lived during the Middle Triassic period, which was just before the time of the first dinosaurs. Scientists used to think it was too heavy on top to walk on land because of its long neck, but newer studies show that most of its weight was centered around its body, so it could walk just fine. Between 240 million and 230 million years ago, a new successful group of animals started to rule the world. They managed to evolve from mostly dog and horse-sized creatures into the biggest monsters that ever existed on Earth. Scientists say they managed to do it thanks to some massive volcanic events. But it's a topic for another video. Life during and after the dinosaurs.
Now, you can't find living dinosaurs nowadays, which is a good thing, mostly, but you can still meet some creatures that might have gone to lunch with them. The frilled shark, for example, is a living fossil that comes from a family of sharks that have been around for about 80 million years. One of the coolest things about it is its long, eel-like body that can grow as long as 6 feet. It has 6 pairs of gills on its throat, which help the frilled shark breathe in the deep, cold ocean where there isn't much oxygen. The shark can move very quickly, like a snake, to catch its prey when it least expects it. Little frilled sharks take an exceptionally long time to grow, up to 3.5 years, which is one of the longest times for any animal with a backbone. The Chinese giant salamander is another living fossil that can tell you what was going on Earth around 170 million years ago. Now, when I say tell, I really mean it, as it can make sounds like hisses, whistles, and barks, and even a noise that sounds like a crying kid. The biggest Chinese salamander found so far weighed 130 pounds, as heavy as 2 Dalmatians, and was almost 6 feet long. Giant salamanders like to be alone. Hey, I want to be alone. And will chase away other salamanders from their space, except when it's time to start a family. During the day, they hide and sleep under rocks. They can make a special substance from their skin that keeps predators away. Now, gharials are reptiles that have been around for about 38 million years. They live in India and Nepal in slow-moving, muddy rivers. Sadly, there are very few gharials left in the wild, less than 100. These creatures can't control their body temperature, so they need to sunbathe to get warm or cool down in the water if they get too hot. Their eyes are close together and face forward, which helps them see in 3 dimensions and judge distances more accurately. Gharials also have a transparent third eyelid that protects their eyes when they're underwater. They have over 100 sharp teeth, but they can't chew their food. Instead, they use their strong jaws to grab prey and then, swallow it whole. The alligator gar is a fish that has a family history of more than 100 million years. It still has some cool features from ancient times, like being able to breathe both air and water. It also has a special spiral-shaped intestine, like a shark. The alligator gar is one of the biggest and heaviest fish in North America. Just like an alligator, it has a long body and snout, plus a row of sharp teeth. But instead of legs, the gar has fins to help it swim underwater. The tuatara isn't a lizard as you might think, and isn't a dinosaur either. This New Zealand resident is one of the most unique animals in the world. Scientists love studying tuataras because they can help us understand how today's lizards and snakes evolved. One of the coolest things about the tuatara is its third eye, called a parietal eye, on its head. It has its own lens, retina, and a nerve that connects it to the brain. Scientists think it might help the tuatara know when it's light or dark outside and absorb sunlight to make vitamin D or help them keep their body temperature exactly right. Tuataras can live an extraordinarily long time, up to 100 years. Cassowaries are the youngsters on our list, as they've been around for only 60 million years. They have some things in common with dinosaurs, like their three-toed feet and how they breathe. Cassowaries love to eat fruit, lots and lots of fruit. This love of fruit helps the rainforest because when cassowaries eat the fruit, their bodies don't harm the seeds inside. As they move around the forest, they spread these seeds, you can guess how, with their own natural fertilizer, helping new plants grow. Cassowaries are big birds, about 6 feet tall and weigh over 100 pounds. They have a special claw on each foot that is 5 inches long, and they can use it to kick real fast. If they feel threatened, they can charge, kick, and even jump on someone. They can also leap up to 5 feet in the air. So, the best thing to do is stay far, far away from where they live. The order Notostraca is a group of crustaceans that you may know as tadpole shrimp or shield shrimps. These animals have been around for about 360 million years. They have a wide, flat shell that covers their head, and they have a pair of eyes on top. These creatures can be found all over the world in different kinds of water, like freshwater, brackish water, and even salty pools. They can also look different depending on where they live. Notostracans aren't picky eaters and can snack on pretty much anything, from plants to small animals and other shrimps. Some of them are considered pests in places like California rice paddies because they stir up the mud, which blocks sunlight from reaching the young rice plants. Sturgeons are some of the largest fish species on the planet. They live only in the cool waters of the northern hemisphere and never travel below the equator. Even though they are huge, sturgeons don't have teeth. They eat by sucking food off the bottom of rivers, gulfs, lakes, and oceans. Scientists believe that sturgeons came from a group of fish that first appeared around 419 million years ago, long before dinosaurs even existed. Their ancestors survived a big extinction event that wiped out 90% of all species and went on to become the largest fish in many rivers in North America and Eurasia. Sturgeons can live up to 100 years old or even older. Female sturgeons can lay up to 3 million eggs at a time, but not all of the eggs eventually turn into real fish. Our next hero, the Pacific lamprey, has successfully lived through at least 4 mass extinctions. Its ancient ancestors evolved over 450 million years ago. These creatures have cartilage instead of bones and a third eye, which is a special light-sensing organ on top of their heads. Instead of a regular jaw, they have a mouth surrounded by teeth. They latch onto prey and sup up body fluids like real underwater vampires. And although he wasn't living underwater, the story goes that King Henry I of England might have lost his life because of a lamprey. The English monarch loved this fish so much that he defied doctors' orders to stop eating its flesh. He got sick every time he'd have it, but the lack of bones and the unusual taste made the royal fall in love with it. As a result, he got some scary symptoms from eating lamprey and eventually passed away. Can you say clueless? The elephant fish, also called the Australian ghost shark, has been on Earth for around 400 million years. Even though they're related to sharks, they aren't actually sharks. Instead of bones, their bodies are made entirely of cartilage. These fish have a special shiny tissue in their eyes that can make their eyes look like they change color from yellow to green. Elephant fish can be pretty tough and will fight back if they feel threatened. They like to be alone and usually don't hang out with other fish. Horseshoe crabs also deserve the title of survival champs, as they've been around even before dinosaurs, since 450 million years ago. 4 species are still roaming the ocean from Maine all the way to Mexico. Horseshoe crabs are more like spiders than ticks than they are like real crabs. They have 9 eyes, plus extra light sensors near their tails so they can see really well. They breathe underwater using flap-like gills near their belly, and sometimes they use these gills to swim upside down. Every spring, when the tide is high, these creatures come up to the beach at night to mate and lay their eggs, and you can see hundreds of thousands of them. If dinosaurs once ruled the Earth, it seems like we should stumble upon their bones everywhere. But we don't. Why is that? Aren't you curious? There's no conspiracy here. The truth is that the quest to find dino remains is much more complex than meets the eye. Yes, dinosaur bones are real, we found tons of them, and they've already been uncovered on every continent, despite many people arguing otherwise. And the uneven distribution of these prehistoric treasures is simply a quirk of nature. Turns out fossilization is an incredibly rare phenomenon. It only happens under specific conditions. When a dino bites the dust, the journey to fossilization begins. The carcass needs swift burial by sediment, followed by layers upon layers, creating a geological pressure cooker. Minerals sneak into the bones, morphing them into stone. This unique recipe predominantly occurs underwater, where sediments like sand and mud can gracefully cloak the fallen giants. Which is why dinos meeting their end above ground rarely end up as fossils. For example, we barely find any fossils of species who lived in the jungle, and especially in the mountains. Researchers reveal that many fossils arise from areas near lakes or rivers. Whether drowned before a flood or carried away by rain, these dinosaurs lucked out in fossil formation. These are the reasons why we don't discover dinos in every nook and cranny. The harsh reality is that we might never meet many dino species, all because of these limitations of fossilization. Around 71% of dinosaurs will never be discovered. We don't even know how many species we've lost due to unsuitable conditions. If we're super lucky, we might find some fossils of mountain dinosaurs in local rivers, but that's a very rare case. So yes, while dinosaurs graced the globe, all the fossils we found so far were due to great luck. Now, this makes you wonder how much dinosaurs lived in general. There are myths about them leading a tortoise-paced life. People believe that dinos were sauntering through centuries to achieve colossal sizes. Funny enough, the truth is exactly opposite. In reality, dinosaurs lived shortly and shone bright like rock stars. Unfortunately, once these animals hit the prime of reproduction, they often found themselves on the fast track to fossilization before reaching their full-size potential. What's interesting is that dinosaur life cycles align with the rhythm of trees. Perhaps you know that it's possible to determine how old the tree lived by its rings. It's true, each pair of light and dark rings equals 1 year of age. Like the rings tell us about trees, dinos' bones tell us about them. Researchers examine slices of bones under a microscope, analyzing different tissues to gauge growth rates. Thick rings mean rapid growth, and narrow ones mean a more leisurely pace. In the animal kingdom, bigger usually equals longer life. So, some people wonder whether big dinos actually live longer. Apparently so. Large sauropod dinosaurs, akin to ancient behemoths, likely took around 30 to 35 years to reach their colossal peak. Following that, they might have enjoyed a few more decades on the prehistoric stage. For smaller dinosaurs, like the nimble arthropods, life was a swift affair. They grew to their full size after around 4 to 5 years of life. But after a mere 3 to 4 years, these mini dinos, unless super fortunate, might have bid adieu. So it turns out many dinosaurs didn't live for hundreds of years. Most of them, even colossal ones, rarely marked even their 50s. It's a surprise if you compare them to today's giants like blue whales and elephants. These animals boast human life spans. Blue whales live for around 80 to 90 years, and many elephants make it to their 60s to 70s. And they're not as big as some dinosaurs. Yeah, it's a pity that they left our planet so early, and we don't have a chance to study so many of them. What's even sadder is that dinosaurs have been doomed from the beginning. Even if a random cosmic rock hadn't hit our planet, dinosaurs would still have gone extinct by today. The Chicxulub meteorite smashed into our planet 66 million years ago. For the record, it didn't actually destroy all the dinosaurs, only the non-avian ones. The rest became birds. Yep, some of these colossal creatures became tiny chickens and pigeons we see today. Guess they know what wolves might feel like. But even before that happened, the Earth was slowly preparing a catastrophe for them. Recent research shows that the era before the asteroid impact wasn't exactly a paradise. It was more like a brewing cauldron of environmental challenges. The scientists delved into the Deccan Traps, one of the largest volcanic regions in present-day West India. They came up with an innovative technique to study the past through volcanoes by measuring sulfur concentrations in rocks. That's how they learned that the Deccan Traps, spewing millions of cubic miles of molten rock, contributed to global climate shifts. Over 100,000 years before the infamous Chicxulub meteor struck, global temperatures might have plummeted by several degrees. This sudden drop was most likely triggered by sulfur emissions from the Deccan Traps. And this, in turn, led to pretty wild, unpleasant climate conditions. The Earth ended up experiencing volcanic winters. This made life super challenging for flora and fauna and set the stage for the eventual dinosaur extinction. So, even if there was no asteroid, dinos wouldn't survive for too long. For a long time, scientists have been arguing whether it was the asteroid that wiped out the dinosaurs or the volcanic activity. Finally, technology is developing, and we can use it to answer this question. An AI system developed by researchers offers its own perspective. Using over 100 processors fed with geological and climatic data, the AI explored the fossil records and over 300,000 possible scenarios to find the truth. And, according to the machine, the volcanic theory is far more plausible. It told the scientists that the climate changes required for a mass extinction were likely caused by the Deccan Traps alone, even without the asteroid impact. The volcanic eruptions coincided with the Cretaceous-Paleogene boundary, starting 300,000 years before the asteroid, and it continued for an extended period. This raised some questions about human versus AI judgment. Some scientists expressed skepticism and talked about the AI's potential bias. But the researchers who led the project are excited about the novelty of their method and its potential to explore other periods of Earth history. However, it will likely take some time for humans to build trust in AI. We already mentioned that non-avian dinosaurs survived this apocalyptic event. For some reason, neither volcanoes nor an asteroid wiped out everything on our planet. Many animals survived, evolving into mammals, and many plants continued to flourish. Plants went through this even better than animals, actually. A catastrophe bid farewell to about 75% of Earth's species, not to count all the individual losses. Yet, botanical wonders survived. Around 78% of our plant species owe their existence to their persistent ancestors. Unfortunately, plants don't turn into fossils as easily as animals do, and we already know that this process isn't quick or common either. So the researchers had to turn to evolutionary trees. They analyzed up to 73,000 surviving plant species. The findings revealed a remarkable narrative of evolution and dominance. Turns out, after the Great Extinction, these sneaky plants seized the opportunity, just like mammals who rose to prominence after the dinosaur era. Major orders, like those of mint, magnolia, and orchids, not only coexisted with dinosaurs, but thrived beyond the extinction. The secret to their success lies in how they could adapt for pollination. They didn't care whether they were pollinated by wind or insects or anything else, basically eating resources from anywhere they could find. Thanks to this awesome adaptability, which scientists call flower power, their legacy lives and flourishes today.
We've all been afraid of the dark at some point in our lives, haven't we? I mean, do you remember getting tucked into bed by your mom or dad after they read you some scary fairy tale with monsters and dragons or even dinosaurs? But just as your parents were about to turn the lights off and silently step out of your room, you remembered. What if there was something hiding under your bed? Or worse, what if some spooky creature was stuck somewhere in the closet? You could probably get up and check, but it was too dark out there. Wouldn't it be great to have some source of light that would come from within your body? You could always use it whenever you get surrounded by darkness. Unfortunately, as humans, we aren't able to do that. But there are a bunch of creatures out there that can, in fact, light themselves up. That's thanks to a little something scientists call bioluminescence. Animals and fish living in the ocean tend to have this talent more often than others. And you can find these creatures anywhere, close to the surface or deep down at the bottom. 2.5 miles deep if you have a knack for numbers. These creatures use their light for a lot of things, like communicating with other members of their species, luring in prey, and even scaring away enemies. Bioluminescence is basically an organism's ability to emit its own light. Chemistry has a lot to do with it. Such animals use two chemicals, one called luciferin and the other called luciferase. Add a bit of oxygen and bam! Light! Should you ever wonder if you actually observe bioluminescence or if someone just dropped a glow stick in the ocean, be on the lookout for neon blue, green, or even red sparkles in the sea. They're usually spread over a large area. This can even make the water look like glitter or a starry sky. You can thank squid, tiny crustaceans, and algae for this romantic atmosphere. Now, I've got another unusual phenomenon for you. How about a golden waterfall? I'm not kidding, it actually exists, and it's a natural phenomenon. To see it, you have to drive to Yosemite National Park to the Horsetail Fall. Make sure to plan your trip in winter or early spring. That's the only time during the year when you can see this awesome phenomenon. It doesn't need any scientific explanation. It's nothing more than sunlight at dusk hitting the waterfall in such a unique way that it makes it look like a river of lava. Or gold, your choice. That's the reason why during this time of year, the Horsetail Fall is also named the Fire Fall. Unfortunately, this phenomenon is becoming less and less visible within the years, mostly because of drought and other issues connecting with the melting of snow. So, should you ever decide to visit, keep an eye on the waterfall, since the effect is very brief. Ever heard of a dirty thunderstorm? It's also called volcanic lightning. Apparently, specialists looking into the phenomenon have yet to fully grasp what it is. When a regular thunderstorm happens, particles with positive and negative charges collide, hence the giant spark we call lightning. It also makes a lot of noise, which you can recognize as thunder. But when a volcano is erupting, some of the volcanic ash particles get electrically charged, and while getting projected into the air with a huge force, they collide and cause electrical discharges. This whole process makes it look like there's lightning coming from the volcano itself. Imagine all that ash, gas, and smoke coming from the crater, and then add some electricity to the mix. It'll make the whole picture look really bizarre. No wonder this phenomenon is called the dirty thunderstorm. Now, how about clouds that look like waves? Those are called asperitas clouds, and they're actually quite close to the ground, unlike your regular day-to-day clouds. The name comes from the word aspero, which in Latin translates to rough or uneven. On rare occasion, you may spot such clouds when the weather is calm, but they're mostly associated with thunderstorms. These clouds appear during unstable atmospheric conditions, and surprisingly, they don't produce rain. Even though they do resemble dark storm-like clouds, they also create random patterns, tricking your eyes into thinking you're looking at the surface of the sea from under the water. Another impressive kind of cloud is called mammatus clouds. What makes them so special is a series of bulges emerging from the base of each cloud. One such cloud enters a level in the atmosphere where the wind direction changes. You can see these wave-like patterns in the sky. Australia is the place for you if you like surfing, but not all the waves you can catch there are made of water. Near a town called Hyden, there's a mysterious wave made out of rocks. This granite formation supposedly dates back to 2.63 billion years ago. That's way before dinosaurs started hanging around the planet. Standing at 49 feet high and 360 feet long, the wave was formed as a result of two processes: weathering and erosion. There's softer sediment at the base of the wave rock, which was chemically weathered by groundwater. Winds and rain did the rest of the job, causing the erosion of the rest of the formation. Its red, yellow, and gray stripes are made of iron hydroxide, carbonates, and other chemical compounds that were washed down by the rain. You've made it to Australia, so stick around a bit more. There's one more location here that seems unreal. You'll need to fly over this one, however, if you want the best picture. In the western part of the country, surrounded by green woodlands, there's a series of lakes. They're all a staggering shade of bright pink. Out of them all, the most famous is Lake Hillier, a 2,000-foot-long reservoir. It's surrounded by both sand and a forest of eucalyptus trees. This makes the cartoon-like hue of the lake stand out even more. One of the many theories explaining the color of these mysterious lakes is connected with algae. These algae appear to gather high levels of a substance called beta-carotene, which has a red-orange pigment in it. Another explanation involves haloarchaea. Those are microorganisms that sometimes look red. Even if you don't enjoy flying, the lakes are great for taking a swim. They're not toxic, even though they have loads of salt in them. This means you'll be able to stay afloat easily, and the water won't damage your swimsuit. During winter up north in Canada, a bizarre phenomenon happens at Lake Abraham in Alberta. Underneath the frozen surface, you can spot some weird objects that look like frozen jellyfish. It's definitely not the case, as these creepy formations are just frozen methane bubbles. Those are pockets of gas that were trapped underwater and got stuck there after the lake had frozen. They appear when leaves and grass fall into the water and bacteria digest them. This process transforms them into methane. This phenomenon is as beautiful and strange as it is dangerous. The pockets of methane can easily become highly flammable. When the temperatures rise during the spring, the ice melts and these bubbles start popping and fizzing. It's a spectacular sight to observe. Picture a lake filled with soda. Remember not to bring any source of fire. It can be very dangerous for visitors. You can check out these types of lakes all across Canada's Banff National Park. Nature often tends to make its own music. Just listen to the sound of crickets at night, or the soothing noise of a waterfall. But in Bucks County, Pennsylvania, there's a strange geological phenomenon which takes nature soundtracks to a completely different level. These are called the ringing rocks, and scientists still can't explain their unusual behavior. If you strike these rocks with a heavy object, like a hammer or another rock, the stones will make a ringing sound, as if they were hollow, but they're not. What makes the ringing rocks even more bizarre, apart from the mysterious sound they make, is that no animal wants to hang around there. Even though the rocks are surrounded by a thick forest, scientists haven't managed to trace any animal activity in the area yet. Even more striking is the fact that despite all the trees around the rocks, you won't find any leaves lying on the boulders. What makes these rocks so unappealing for both animals and vegetation is still up for debate.
Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash. A massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly. 5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami, with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash. A meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash. The dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, but if they fell, they could never get back up. The smaller dinosaurs like Triceratops had short legs and couldn't go through the dense swamps. 1 month after the meteorite crash. 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made photoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space. It wasn't the impact itself that made the dinosaurs disappear. The fire destroyed most of the plants the herbivorous dinosaurs ate. With no food, their numbers dwindled rapidly. Predatory dinosaurs had nothing to eat either. Acid rain and the disappearance of phytoplankton threatened all marine life. Even though birds managed to avoid the blast waves and tsunami, they were short of food too. About 80% of all birds didn't make it to the end of the extinction event. The problem was that all of the forests on Earth were wiped out. Most birds would nest and live in trees. Besides that, the forests were always full of food, from all kinds of ants and termites to flying insects and small mice. So, only those species that lived on the ground and could fly well survived. Most likely, they fed on the seeds of small surviving plants. This habit made flying dinosaurs lose their teeth during evolution. Instead of jaws with a bunch of sharp teeth, they got long beaks to grab tiny seeds from the ground. Although Earth looks like a terrible place to live now, there's an evolutionary boom for birds. They have to travel long distances in search of food. Their wings get stronger. They also feel safe from predators who regarded them as food before. No T-Rex now catches a sleeping bird off guard. About 1,000 years after the collision, the first dense forests appear. It gives another boost to evolution. 1 million years later, forests full of food are populated by the ancestors of modern mouse birds. And 65 million years later, in modern times, we have about 10,000 species of birds. Pigeons, crows, eagles, and hawks, even penguins. These are all descendants of the dinosaurs. But there were other survivors. Some alligator and crocodile ancestors were able to adapt to changing conditions. About 80% of turtle species managed to survive the mass extinction, and now their descendants live among us. Snakes and lizards were also able to wait out the hard times in their burrows. Even some mammals, like monotremes, survived. This hedgehog-sized animal was able to continue to evolve. Many millions of years later, these mammals evolved into primates, which later gave life to modern humans. Much, much later came the iPhone.
Over 100 million years ago, dinosaurs were all the rage, and mammals cowered in their huge shadow. But then, there was a badger-like creature that lived in Asia at the time, where most mammals were small and quick to get away from trouble. The Redefining was way bigger. It was the size of a large dog. Researchers think this creature wasn't too fast because it had short legs, but it was surely a carnivore, and surprisingly, there were dinosaur remains found in its fossilized belly. Turns out mammals were already evolving to rival the huge reptiles, and Redefining was one of the first to hunt them down instead of being hunted. It's not clear yet if the giant badger was a hunter or a scavenger, but it was big and bulky enough to be both. Dinos beware. Then there was the Oumuamua. You could easily carry it around with you, but whether you'd want to is another matter, because it had not one, not two, but 5 eyes. The Oumuamua looked so strange that when scientists reconstructed it in 1972, they first burst out laughing. The Oumuamua had a trunk-like mouth which it used to fish around the mud for food, but because it didn't have teeth, it probably only ate soft food. The terror bird, a large carnivorous bird that looked like it stepped out of a horror movie. It had a sharp beak that had the force of a sledgehammer, which wouldn't have been good news for its prey. The terror bird was one of the most dangerous predators in South America during its time. It was a flightless bird, but it was also a very fast runner. The only way to outsmart it was to take sharp turns while running, for these birds could only run fast in a straight line. The megalodon was the largest fish that ever lived. Female megs were nearly twice as large as the males. Its name, megalodon, means big teeth, and no surprise, its teeth were 3 times larger than those of the great white shark. The megalodon appeared after the dinosaurs became extinct. Now, it's extinct too, but when it was alive, it seemed to have lived in nearly all parts of the world, except Antarctica. If you thought modern-day piranhas are bad, you should have seen the mega piranha that lived in South America millions of years ago. If you compare its size to a dog's, it was as long as a golden retriever and weighed as much as an adult cocker spaniel. The mega piranha could exert a force up to 50 times its own weight. Pound for pound, that's more powerful than even the T-Rex's bite. There were lions in North America that disappeared around 13,000 years ago. This was around the same time that mammoths went extinct. These lions were almost 25% larger than those of today. Fossils of these ancient lions were discovered in the La Brea tar pits in Los Angeles, along with many other interesting creatures. An armored fish, the Dunkel osteus, didn't have teeth, but that didn't matter because it had razor-sharp bone protrusions that were like a pair of shears. It could snatch its prey by opening and closing its mouth at a speed of 50 milliseconds. Some scientists believe the Dunkel osteus swam sideways like an eel. Fossils of this fish can be seen in many museums all over the world. The Titanoboa was the largest snake ever discovered. This giant crushing machine was even able to consume a crocodile. It lived 60 million years ago in the tropical forests of South America and looked more like a boa constrictor, but acted like a water-dwelling anaconda. Although the Titanoboa is now extinct, people still find it fascinating. There is a full-scale replica of it in Midtown Manhattan. The Tully monster lived 300 million years ago, but researchers learned about its existence only about 60 years ago. From what we know, it had a soft, torpedo-shaped body and vertical fins. The Tully monster was one of the most bizarre creatures ever, and scientists just couldn't figure out what it was. First, they thought it was a type of worm, then a sort of squid. Now, they say it's closest to a lamprey, which is a parasitic fish. The largest member of the canine family was the Epicyon, which is now extinct. The term Epicyon means more than a dog, and it certainly was. It was as long as a lion and weighed just as much, and its huge skull had a lion-like shape to it. The Epicyon may have either gone after prey or scavenged for food, but they ate everything from rhinos to horses. There was nothing to smile about if you ever came across a Smilodon, but don't worry, it went extinct many years ago. This saber-toothed tiger lived in the forests of North and South America until 10,000 years ago. The Smilodon had impressive upper body strength, which helped it wrestle its prey to the ground. This was bad news for all the mammals in its area because it was especially fond of having bison and camel for breakfast. The Jachyllopterus was a giant scorpion that lived in Germany 400 million years ago. It was longer than 2 yardsticks laid end to end, and it was the largest arthropod that was ever discovered. Its fossilized claw, found recently, was longer than a loaf of bread. The Jachyllopterus was called a sea scorpion, but it preferred to live in rivers and lakes. It was not a picky eater, and it ate fish and other aquatic animals smaller than itself. Even the smaller ones of its own kind weren't safe when the larger ones were around. One of the biggest flying insects of all time was the Meganeuropsis. It looked like a dragonfly, but its wingspan was unbelievably wide. These insects probably grew so big because there was more oxygen in the atmosphere then. which fueled their growth. Meganeuropsis lived in North America in the prehistoric era. It was so big and hungry that its diet included small lizards and young amphibians. To get rid of this creature, only a swatter larger than a table would be of any use, and a piece of its wing is still preserved at the Harvard Museum of Natural History. Whales were once land dwellers and moved to water only 50 million years ago. The Basilosaurus, despite its name, was not a dinosaur, but one of the first marine species, and it was much larger than other early whales. It was longer than a 4-story building, had a gigantic head, and a bite to rival the T-Rex. Fossils of some smaller whales carry the teeth marks of the Basilosaurus. This is not surprising, since it was one of the top predators of its time. It ate nearly anything, but its favorite food seemed to be dolphin-like creatures. If you thought grizzly bears were bad, you should have seen the Arctodus simus. This short-faced bear could run really fast, faster than wild horses and antelopes. One study suggests this bear consumed more meat in a day than most people would eat in a year. It used to dwell all across North America until 11,000 years ago. It used its enormous size to intimidate smaller predators, such as saber-toothed cats, American lions, and dire wolves. If you don't like rats, then the Joseph-Fortigacia will be your worst nightmare. The only thing worse than its name was its size. In fact, this rodent was as large as the bull of today. The giant rat lived in South America around 3 million years ago. It had fearsome front teeth that enabled it to ward off predators. It also made full use of those cutters to crop grass and other vegetation. The first bird was the Archaeopteryx. Some say it was the missing link between birds and dinosaurs. It was actually very small, no bigger than a raven. This animal had very sharp teeth, 3 fingers with claws, and a long bony tail. The Glyptodon was one of the armadillo's ancient relatives. Heavily armored with a round bony shell, it looked like a turtle, but was as large as a car. It was an herbivore, but it had a flexible bony tail, which it used to defend itself from predators and to fight its own kind. The Neuralagus rex was the T-Rex of rabbits, and it was nothing like the cute bunnies we're used to. For one thing, it was massive, weighing 6 times as much as the European rabbit of today. It ate roots and yams and lived in an idyllic insular environment that had no natural predators. Perhaps that's why it could grow so huge.
And here you are, on Earth, 66 million years ago. It's one of the warmest periods in the planet's history. There are no ice caps yet. Everything is lush and green. Dinosaurs roam the Earth. Massive sauropods peacefully chew on flowering plants and trees, their young ones following closely by their side. You strain your neck to see their heads 5 stories above you. But that's when you see something else. A bright spot in the sky. A shooting star. Make a wish. Wait a minute. The star grows bigger, brighter. Little do the mass reptiles know. Today marks the beginning of one of the largest mass extinction events in Earth's history. 3/4 of life on our planet will be wiped out. Hey, we'll just hide over here and watch. 5 seconds before impact. The meteorite rips a hole through our atmosphere like a needle in a balloon. The resulting supersonic shock wave starts to ripple around the globe. You'd hear it on the opposite side of the planet. The cosmic monster falling toward the Earth is the size of Mount Everest, at least 6 miles wide and weighing 460 trillion tons. The meteor is coming in hot and fast, 12 miles per second, heading right for the Yucatan Peninsula in present-day Mexico. At that speed, it could travel from LA to New York in under 4 minutes. Impact. The mountain-sized asteroid smashes into the Earth. If only it had been anywhere else, life on this planet might look a lot different today. The Yucatan Peninsula, almost entirely underwater then, was one of just 8 places on the entire globe that would have let a giant space rock wipe out nearly all life on the planet, meaning the asteroid only had a 13% chance of causing a mass extinction, and it happened to hit just the right spot. Well, aren't we lucky? At the point of impact, there's an explosion 1 billion times more powerful than even the most massive volcanic eruption. It looks like a new sun has appeared on our planet's surface. The meteorite digs into the Earth's crust and explodes into 1 million pieces. You can still see the scar it left. The Chicxulub crater is 93 miles wide and 12 miles deep. It could fit the entire state of Vermont and 24 Burj Khalifas stacked on top of each other. Something that leaves a scar like that has global consequences. The Earth ripples. The shock wave spreads for thousands of miles. The air blasts flatten forests in a second. Everything within striking radius is set ablaze. Nothing survives ground zero. But that was just the beginning. Smaller fragments of the meteorite, as well as parts of the Earth displaced by the giant hole it dug, go ricocheting out, reaching as far as Canada. The sky lights up with fireballs. They smash into the surface as well. Dinosaurs that weren't in the blast radius run in panic, but they have nowhere to hide. It's only about to get worse. The shock waves race across the sea. The tsunami is nearly a mile high when it hits the coast. The waves keep traveling, reaching the furthest corners of the planet. Even across the Pacific and up into the North Atlantic, they're 5 stories high. They wash away everything in their path. Besides the raging fires and skyscraper-sized tsunamis, the Earth is shaking from the worst earthquakes in history. A planet lush and teeming with life only a few minutes ago has turned into a nightmarish place. But this was only Phase 1. 5 minutes after impact. Small rocks, dust, and ash rise high up into the atmosphere. These objects heat up and melt. They turn into hot lava that begins to fall to the ground like burning rain. 10 hours after impact. Fires continue to engulf everything in their path. Some surviving dinosaurs in North America try to escape to unknown territories, but now they're in dense swamps and can't escape. 1 month after impact. 15 trillion tons, 2.5 million times the weight of the Great Pyramid of Giza. That much ash and soot are released into the atmosphere. The cloud covers the entire planet and blocks out the sun. The Earth sinks into darkness. Surviving plants can't photosynthesize. Oxygen levels drop. Any animals left at this point are finally done in from lack of air. But the worst consequence was the extinction of phytoplankton. The entire oceanic food chain starts to collapse like a house of cards. Many marine animals have lost their main source of food. Surviving animals on land also can't find anything to eat. There are no plants for the herbivores, and soon no herbivores left for the meat-eaters. And still, there's the acid rain. The Chicxulub meteorite hit a place where there was a lot of sulfur. The heat of the impact vaporizes the toxic gas instantly. It mixes with the air in the atmosphere. Acid rains fall all over the planet. The oceans become toxic. And if all that doesn't get them, the cold finally finishes off the job. With the sun blocked out, the burning fireball that is our planet starts to cool down. What's left in the wake? Plants are a little luckier than animals. Seeds and pollen are able to survive these harsh times. The first to slowly paint the charcoal planet green are ferns. The wind carries their seeds, sprinkling them across the Earth over 10 years. Then come the palms. The new planets produce oxygen and feed small mammals. Of the reptiles, only turtles and ancient ancestors of crocodiles can survive the temperature and acidity of the planet's waters. Unbelievably, some bird-like dinosaurs survive too. Other species of birds evolve and survive to this day. Sadly though, all terrestrial animals over 50 pounds in weight went extinct. It took much longer for the animal kingdom to recover. Larger mammals, such as rhinos, began to appear only 15 million years after the dinosaurs disappeared. Blue whales, the largest living creature this planet has ever seen, bigger than any of the dinos, only showed up a little over 4 million years ago. Did the dinos have a fighting chance? Scientists say that if the meteorite had hit in the deeper ocean, the story would have gone a lot differently. Yes, the resulting tidal waves would have been 10 times higher than the already massive ones that rippled across the planet. But even a giant mega tsunami wouldn't be able to wipe out 75% of plant and animal life on Earth. What really did the dinosaurs in was the global blackout. If the meteorite had hit in deeper water, not the shallow sea of the Gulf of Mexico, there wouldn't have been so much dust and ash in the atmosphere. That dropped the oxygen levels and cut off the food chain from the very bottom. There's a theory that climate change and other conditions on Earth 66 million years ago would have still wiped out the dinosaurs, no meteorite necessary. It could be a supervolcano erupting and spewing out large amounts of sulfur and ash into the atmosphere. Perhaps the meteorite just sped up the inevitable. Now let's move on to a more interesting question. Could humanity survive a meteorite impact like that? Back then, not a chance, obviously. But if something like that were to happen in our time, we have an advanced intellect and technology. We've filled the cosmos with probes and satellites, so we know about any possible meteors headed straight our way. It wouldn't take us by surprise. Now, we might have to hide deep underground to avoid the blast wave and tsunamis, and you'd need enough food down there to last for at least a year. And don't forget your toilet paper. But with the right prep, humanity could stand a chance. The main problem after such an event is to survive the global winter when the ash covers the sky. But our species can handle it. Just ask anyone living in Oumuamua, Russia. The town of 500 people holds a Guinness World Record for the coldest inhabited place on Earth. They've seen the thermometer read minus 90 degrees Fahrenheit. What about preserving plant and animal life? Our species has been working on that for a long time. There's a World Seed storage facility on Svalbard Island. It's about 40 stories underground and can hold over 2 billion samples. The location was chosen because of the permafrost climate and low tectonic activity. Preserving all the planet's animals would be a tougher job. Perhaps genetic engineering, cloning, or something else would work. Herding them all down into a bunker